Hi, I'm Olga Mali and this is Math Talk. Today our topic is graphing linear inequalities in two variables and I have a guest. My guest is Ty Lewis, student of our college. Hi Ty.
Hi Professor Mali.
Good to have you again here in our studio. So that's what we're going to do today, graphing linear inequalities. And we will start with one inequality. 3x plus 2y greater or equal to 4. So what is solution of inequality in two variables? It's collection of all points with coordinates x, y, which would make our inequality true statement. And we will have infinite number of those points. Actually, result solution set will be half of coordinate plane. So it will be some line somewhere and half of coordinate plane will be solution. So to find solution of a linear inequality in two variables, first we need to find this line, which will be called boundary line, and then we need to decide where do we go from this line. Do we go to the right or we go to the left? So let's have a look at my example now, and we will be moving according to steps of my procedure. So here is our inequality again, 3x plus 2y greater or equal to 4. So step number one, we replace inequality symbol with equation symbol. So Ty, can you do it on the other side of the board?
Okay, so we we just replace this with an equation symbol, the equal sign.
So what we got here, this is now equation of that boundary line. So our next step number 2, will be to graph the boundary line. There are different ways of graphing it. So how can we graph it? We can use 3 points, we can use x and y intercept, or we can just use slope intercept form. Yeah, solve for y. Okay, so let's do it.
So we'd subtract the x, the
3x. So it's negative
4 minus 3x.
Okay.
And then
let's just rewrite it with 3x going before 4, because in slope intercept form, I will remind we have y equals mx plus b. So let's follow that. Okay, so negative 3 over 2x
plus 2.
Plus 2. Great. So now we have this will be y-intercept and this will be slope. So how do we graph this boundary line? So we need to start with y-intercept. This is 2. Y-intercept should be on y-axis. So this is our y-axis, this is our x-axis. So 1, 2. So this is 2. This is point where we start. So what do we do next?
So now we have to move. Remember, the slope is equal to the rise over the run. So negative
rise over run.
You'd have to drop 3 units to -1, and then you'd have to go to the right 2 units. So our other point would be right there.
Okay, great. So we move down 1, 2, 3, and we move to the right 2 units. So this will be our line. Now, question. Lines can be different types. Lines can be solid, or lines can be dashed. So in what case we have solid line, in what case we have dashed line? Do you remember?
So a solid line would be, a solid line is if it includes an equals sign.
So when we have signs like this,
greater,
sign
equal,
of
or less than equal.
So line is
dash,
included. And
dash, we just have greater or less.
Greater or less. So line itself is not included in our solution set. So in our case, we have equal symbols. So our line will be solid line. So okay, let's just graph our line. So this is the line. Okay, very good. Now we need to decide how do we shade our half coordinate plane? Do we go to the right
This
or we
way
go
or
to the
that way?
left? Yeah, do we go that direction or we go this direction? So that will be our step number 3. We need to use test point. Test point. And the most convenient test point would be 0, 0, but there is a condition. Test point should not be on the line, not on the line. So we need to pick convenient point, which is not on the line, and substitute coordinates of that point into our original inequality and just check if it is true statement or not. So we have 3x plus 2y. So Tai, can we take 0, 0 point? Can we
Yes,
take this
because
point?
it's not on the line.
Yeah, it's not on the line. We can see it from our graph. So we can write 3 times 0 plus 2 times 0. Will it be greater or equal to 4? So what do we have? We have 0 greater equal to 4, and this is false. False. So this is false. That means, how do we go with our shading? Do we cover 0 or we go away from
We
the
go
0?
away from 0, 0, so it would be
Yes.
this way.
So that's how we do it. So this will be our solution for this particular inequality. Now, let's just complicate our problem a little bit. Let's consider 2 inequalities together. So our first inequality is green color, 3x plus 2y greater or equal to 4, and we just did it. So I will just copy our picture for this inequality here, solution of this inequality. We just graphed it. So our graph was going through 2, and there was point here. So that was our boundary line, and we know that our shading is on the right. Now, this is one inequality. Now let's do another inequality. So we have system of 2 inequalities. The second one is x minus 2 less than 0. So now we need to graph this blue inequality. We do the same 3 steps. So what was the first step?
So the first step was to see if this was an equal sign, to see
So
if
we
it was
replace inequality symbol into equal symbol, and we get equation of boundary line. So step number 2, we need to graph this line. Will be line solid or dashed?
It would be dashed because that's not equal.
Yeah, it will be dashed line. And so we have x minus 2 equal to 0. We can just write it as x equal to 2. So this is our line. Now, Tai, will it be horizontal line or vertical line?
Vertical line.
So it's vertical line passing through 2. So let's put it on the same coordinate plane. So this is 2. And this will be our dashed line passing through 2. Now, again, we need to determine which way we will go from that line, to the right or to the left. So what can we do? What can be test point?
0, 0.
Yeah, we can take 0, 0 because 0, 0 is again not on our line. So we're using 0, 0 as a test point, and we substitute 0, 0 in our original inequality. Now our inequality has only x, no y, so we just use 1, 0. 0 minus 2, will it be less than 0? So we get negative 2 less than 0, and this is indeed true. So that means our shading should cover our 0, 0 point. So 0, 0 is a point from our solution set. So we cover 0, 0 with shading. And now from here we see very clearly where 2 shadings overlap. It's in this corner. So this region will be solution of our system of 2 inequalities in 2 variables.
And this is an infinite number of points.
Yes.
So if you pick any point that's within this red region, it will satisfy both inequalities.
In the same time. So any point from red region will make both inequalities true statement. Now there is just a shortcut for this type of inequalities. If I just rewrite it as x less than 2? It just means that all x's should be less than 2. So I can go from our vertical line to the left right away. To use this, I can use again this blue color, and we will be on the left side of the line. Okay, let's have a look at another example. And again, let's have two inequalities. So the first inequality is 4x minus y is less than 0. And another inequality in this collection is 3y plus 12 greater or equal to 0. So again, we need to find all solutions of these two inequalities. So all those points which would make inequalities as true statements at the same time. Okay, let's start from the first one. So we have here 4x minus y less than 0. So Tai, continue. Step number 1. What do we do?
So our first step would be to turn the inequality symbol into an equal symbol.
Okay, so this is equation of our boundary line. Will be line solid or dashed?
It would be dashed.
Okay, let's just write it here so we would remember that line is dashed. So how to graph it? Would you solve it for y again?
Yeah.
Okay.
This would be, we'd add y to both sides, so this would be 4x equals y, or just y equals 4x. And this is a pretty easy function to graph.
Okay, I will make here our coordinate plane. So this is x and this is y-axis. So how do you graph this line?
So it would go through the origin, but it would also go 1, 2, 3, 4, and 1. So this would be our other point. And so the line would look something like this.
Yeah, the only thing that line should be dashed. Remember, we just write it that it should be dashed. So let's just erase the line and let's make it dashed, okay? So we will correct our coordinate plane, and we can rewrite it just to see it better. Why the line should look exactly like Tai drew it. This is 4 over 1x plus 0. So 0 is our y-intercept. So we start from 0 and then we count 4 units up. This is right, and 1 unit to the right. And yes, the line will be dashed going like this. Okay, so now we need to decide which side of coordinate plane we should shade, to the right or to the left from our line. How to do it? Can we take 0, 0 point again?
No, because it's on the line. So I'm going to take the second best point.
Okay.
1, 1.
You want 1, 1? Okay, let's take 1, 1. So our test point will be 1, 1. So 1, 1 is located somewhere here. It's not on the line. So we use 1 point in our original inequality. So what do we do?
4.
4 times 1 minus 1. We're checking if it is less than 0. So
4 minus 1, that's 3, is less than 0, which is obviously false.
So this is false, which means which direction we need to go? To cover the point or away from the point, right? Okay, so this is our shading for this inequality. Okay, let's talk about the second inequality, and I will just make it red color. So 3y plus 12 greater or equal to 0. So step number 1, what do we do?
Replace it with an equal sign.
Equal to 0. Now we've got equation of the line, which is boundary line for the second inequality, which would divide solutions from non-solutions. So how do we graph this line?
So we can actually
solve it for y, right?
Yeah.
The same thing.
This would be 3y minus 3y equals negative 12.
Negative 12.
Or y equals negative 4. Okay. Oh, and by the way, you could also divide by 3 the whole equation, and then you get the same number.
It's the same, yeah. So y is equal negative 4. What kind of a line is that?
This would be a horizontal line.
Wait a second. We need to decide. Line will be solid or dashed before we draw it?
Solid.
solid. So let's just write it here so we would know. Okay, this is solid line passing through -4. 1, 2, 3, 4. So let's draw a solid line, red color. Okay, very good. So now we need to decide, do we go up from this line or we go down from this line? Can we take 0, 0 point again as test point?
Yes, we can.
Yeah, it's not on the line, it's here. So let's try. What do we need to write? 3 times 0 plus 12. Will it be greater than or equal to 0? So this means 12 is greater or equal to 0, which is what? True. This is true. So we're moving up from this line. And now, Tai, can you see where two regions overlap?
Yes, it would be in this region right here.
So we just emphasize it with blue color. Very good. So let's just make it even bluer.
It would go all the way up here.
Yeah, so it will be this corner, this part of coordinate plane going up to this line, but this green dashed line is not included. So that would be our solution of system of inequalities, which we have here. And again, when we look at this inequality, we can use a shortcut. Can we just solve it from here for y? We will get that y, let's 3y is greater or equal than -12 and y is greater or equal than -4, which means that we need all y's which are greater than -4, which means we would go up from -4. This was -4 point. So all points which are located in our blue region here, all our blue points, they would make these two inequalities true statements at the same time. So this will be solution of this system of inequalities. Okay, Tai, that was great. And I hope it would help our students a lot, because some of them do have some troubles with graphing inequalities. So thank you again.
Thank you so much. My pleasure.
That was Math Talk and Olga Mali. Thank you for watching.